All right, we're going to talk about classifying triangles. We've got 7 different triangles on the board. The first 3 we're going to classify by sides. Okay, the first one I've got 1, 2, 3 equal sides. So we call that a equilateral. All right, in our second one, we've got a triangle with 2 sides that are the same. We call that isosceles. In our third, we've got 3 sides that are all different. That is a scalene. Okay, in the bottom 4, we're going to classify by angles. And the first one, it's just like my equilateral, except for this time I've got 3 equal angles, which is always true of an equilateral. If you've got 3 equal sides, your 3 angles are all 60 degrees. So when they're all 60 degrees, if we're classifying by angles, we call it equiangular. Okay, in this one, I've got an acute angle, and an obtuse angle. We call this one obtuse. Here we've got a right angle. So if we're classified by angles, we classify that as a right. And lastly, if I have 3 acute angles, we call that an acute if we're classifying by angles. So when we go back even further and we want to classify by angles and sides, 3 acute angles, so that would be an acute isosceles. Okay, if this was a 90-degree angle, that would be a right scalene. So every single one of your triangles you can classify by a side and by an angle. All right, next we want to talk about how to classify these and how to find out the side lengths from a coordinate plane. So in the last section we talked about the distance formula, and this kind of builds off the distance formula. All right, if I've got let me space those out a little better. If I've got a point at -3, -1, I've got a point at 1, 1, and I've got a point at -1, -3. And I were asked to classify this triangle by sides. Okay, I would need to go in and I would need to find the length of each line. Remember, to do so, we could use our distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, meaning I could go in and I could plug these points in. So I could use 1 minus -3 squared plus 1 minus -1 squared. That turns into 1 plus 3, which is 4. That turns into 1 plus 1, which is 2. That's 16 plus 4 gives me the square root of 20. So this side length would be the square root of 20. Now I would have to do the same thing for this length and the same thing for this length. And I would compare. If all 3 sides were the same, it'd be equilateral. If 2 were the same, it'd be isosceles. Well, I'm going to do this a little different. I'm going to look at the change in y and the change in x. Notice if I go from -1 and I go up to the next y value, there's 1 unit, there's 2 units, and I look at the change in x. There's 1, there's 2, there's 3, there's 4. Okay, and for now, I just leave it that way. I'm going to do the same thing on these 2 points. 1, 2, 1, 2, and I'm going to do the same for these 2 points. 1, 2, 1, 2, 3, 4. Now I can already look and see, okay, if I use the distance formula in this, I'm gonna have to square this and add it to that squared. Do the same here. Well, I can already tell those 2 sides are gonna be the same. And then I can tell squaring this and squaring that is gonna be smaller than if I squared both of those. So that's gonna be a 3rd side. So notice these are the same, that's different, which makes that an isosceles triangle. All right, the last thing we want to talk about on triangles is how to determine if 3 numbers can make a triangle. So if I have 3 numbers up here, what has to happen in order for these to make a triangle? If I add 4 and 5, it has to be larger than 8. Well, I have to do the same other way. If I add 5 and 8, it's got to be larger than my 3rd side. Or if I add 4 and 8, it's got to be larger than 5. So if you think about, say that one was 4, that one was 8, and I know this is not drawn to scale. Let's switch those, make it a little better. Whenever you add any 2 sides, it's got to be larger than the 3rd. If you add these 2 sides, it's got to be larger than 3rd. If you add these 2, it's got to be larger than 3rd. So this, if I add 4 and 5, I get 9, so it's larger. 5 and 8 is 13, is larger than 4. 8 and 4 is 12, is larger than 5. So that is a triangle. But if I look at numbers like I can add 8 and 5 is larger than 6. 6 and 15 is larger than 8. But if I add 6 and 8, I get 14, which is smaller than 15. So that could not be a triangle. What would happen is you would get a long side of about 15. You would get a shorter side of about 8. And then your 6 wouldn't be long enough to reach down all the way to that 3rd number. All right, so if we've got 2 numbers, or 2 sides of a triangle, we need to figure out what that 3rd side could be. So I'm gonna have a range of numbers it could be. And the way I think about this is if I've got a number here, what can my smallest number be that I can add 4 to and it'd be larger than 8? And then I think about a number here. Okay, if I add these 2 numbers together, it's got to be larger than that number. So the easy way for me to do this is if I take my numbers of 4 and 8, my 2 sides, I do 8 minus 4. This number has to be greater than 4. Okay, because if it's 4, it equals, but it's got to be more. So I mean, in reality, that could be 4.1, and that would work. But either way, it's got to be greater than 4. Okay, so I subtract them. Next, I'm going to add them. 8 plus 4 is 12. Well, if I put 12 in here, it equals that. So I need this number to be less than 12, so this one's bigger. So this has got to be less than 12. So if you think about this, any number larger than 4 or smaller than 12 would make this triangle work. So we would write our answer, x has got to be larger than 4, but smaller than 12. Anywhere in between there would work. If x were 5, it would work. If it were 11, it would work. Just anywhere in between those two numbers.